We are the Target Capstone team, and today we will be presenting you with deploying and evaluating DevOps automation tool with Chef, Docker, Ansible, and Kubernetes. So this is our team. I'm Caleb Franklin. I'm the team lead and senior Chef engineer.
I'm Austin Redman. I'm the senior Ansible engineer.
I'm Brian Mullen. I'm the junior intern Docker engineer.
And I'm Austin Peltzman. I am the senior Kubernetes navigator.
So our sponsors are the Target Corporation. We just want to extend a thank you to them. And we also want to extend a thank you to Jacob Lube and Jordan Sussman for helping us when we got stuck on this journey.
So for the agenda, we're actually going to start off by explaining to you guys what is actually DevOps. From there, we're going to lead into the problem statement to say what we're working on for this fictional company we have. From there, we're going to go into the tools of the trade and actually show you a little bit of detail on each one of the tools. And then we'll lead into a live demonstration to show you some of these tools. From there, we're going to go into the recommendations and finish up with lessons learned.
So what is DevOps? DevOps is really the joining of two different disciplines. So you have your development and you have your operations. And for the longest time, it was always the developers were changing and updating and innovating with their coding, and then operations, infrastructure, we want stability, we want things to always be working and functioning correctly. So what DevOps does is basically it merges these two groups together and has them collaborate. So what are the benefits of DevOps? So you're going to get repeatability in like the coding aspect. You're going to have that constant ability to keep deploying and keep moving forward, as well as scalability. That's going to be a lot with the operations and being able to just keep moving forward. And that's going to equal some cost savings in the business part of it.
So what was our project actually about? Essentially, we moved forward under the assumption that we were working for a fictional company named Wayne Enterprises, who are looking to switch over to a DevOps solution to change their network infrastructure over to. Mainly because their current infrastructure suffers from a few issues. It takes too long to update the code. It usually results in some downtime, and this downtime tends to result in the loss of profits and costs over time. So that's where we come in. Essentially, our task was to research, deploy, and compare and contrast these different DevOps tools and try to find a solution that best fits the statement of work given to us by Wayne Enterprises. Overall, what we were hoping to do was achieve a few business goals, such as cutting costs, increasing productivity, allow for continuous deployment, and allow for more collaborative efforts.
So from here, we're actually going to go into the tools of the trade that we use. So these are the DevOps tools we use. We're going to start off with Docker, leading into Kubernetes. From there, we're going to lead into Chef and finish it up with Ansible.
So what is Docker? Well, Docker is a containerization service that basically allows you to take a custom application or an open source application and containerize it, and gives you some app isolation. But what's a container? A container is basically a really small, inefficient VM. That's really all, a virtual machine. That's all it is. So what are the use cases of Docker? Why does Wayne Enterprises want this tool? We're mainly targeting that developer productivity, the app isolation, and of course the rapid deployment of Docker. Now, how are we going to implement that for Wayne Enterprises? Well, Wayne Enterprises has their existing application there at the end. We're going to convert that to a container. Then we're going to push it up to Docker Hub or any Docker registration service. And then we're going to be able to pull it down to any location that we want. So that will allow for that rapid deployment that we're looking for.
Well, Docker is a magnificent tool for pushing different software and their configurations across several different hardware. Limitation you might find is that as you expand your network and you get more containers, you'll find that it becomes quickly overwhelming. And so you'll want some management software, and that's where Kubernetes comes in here. Kubernetes is ancient Greek for helmsman. It was created by Google initially under the name Borg, which they actually kept hidden from the rest of the world for like over 10 years because they thought it was gave them that big of an edge over the competition. So what exactly does Kubernetes do? How does it work? Essentially, those containers that were mentioned by Brian for Docker can be put into these things called pods. And these pods are set to follow a specific set of instructions. You feed it through what are called YAML files. I believe JSON files can also work. You might have heard of those throughout the day. There are three major things that Kubernetes sets out to do. First is space efficiency, second is scalability, and the third is the ability to be self-healing. So how does it accomplish all these? Essentially, it has the ability to take a look at what network resources you have running. We'll show you a little bit of how it can do that later. And it'll essentially take a look at what's available, load balance, and set all of your containers into the most efficient places possible, thereby giving you the most efficient use of your resources and your costs. It even has the ability to detect when something goes down. It'll automatically load balance and move your containers over to the other sections, and thereby completely removing downtime almost altogether.
So we're going to move on to Chef now. So what is Chef? It's really a configuration management tool. It allows us to automate through our infrastructure. So a little brief history on who created Chef. So Adam Jacob created Chef. He was actually working for a consultant company, and he decided he could do what they were doing more efficiently, and he developed a program. He titled it Marionette and decided he didn't like that, so he changed it to Chef. Now we're going to get to a little bit of like how Chef works. So Chef is a server-client application. You have your development environment in your workstation, where you develop your cookbooks and your recipes. You upload that to your server, and then your clients, which can be virtual machines, can be containers, can be bare metal, can be cloud, are automatically polling and updating using the automation through the recipes, which I'll talk about in a little bit. So just a little bit about the process of setting this up. So you have to bootstrap your initial workstation and any clients to there. You have to do it manually for the first one, but once you get it manually set up with the correct certificates from your server, then you can just use a knife command, and it'll automatically deploy to all your other clients. So it makes it super, super simple. This is just to show what the Chef server management page looks like. So this is the nodes. This is your clients. You can name your nodes. It gives you the IP addresses, and fully qualified names. You can see run lists. There's a whole bunch of extra data there, and you can tie in with so much other programs as well. So just a little overview of the cookbook. So the cookbooks is really like, it's your whole automation process. So you have your files. The main ones being the files, it's going to be like your actual file system. So like for Wayne Enterprises, I had a Wayne web app, I had MariaDB cookbook, files, all of that was in there. And then the recipe, the default.rb, is actually just the default automation process that it goes through. So recipes, super simple. Every snippet here is like a specialized command that Chef runs. So the yum package installs all those packages in the CentOS machine. Remote directory just pulled all those custom files down. The Nginx just sets it up, installs it, and then I used a custom bash script to run pip 3.6 to install Django on the machines. So what does deploying look like? Deploying, super simple. You're on the client, you can run a Chef client to manually pull down the cookbook, or you can actually add just a simple switch and have it run on like a 5-minute, 30-minute timer, and it'll constantly pull down. This is just a snippet of the Wayne web. Everything was already installed, so it just basically went through everything and said, oh, everything's up to date, we don't have to worry about that. So now I'm going to actually hand it over to Austin R here, and he's going to go a little bit about what Ansible does.
All right, thank you, Caleb. So Ansible was created by Michael DeHaan in 2013 when he was working for a company that really started him off to create it because of the fact that it was using Puppet to try to automate all of its processes it was using through OpenStack. So most of his time spent working with that company using Puppet ended up actually making him bang his head against the desk trying to create it. So now let's go into a little bit of the topology of how Ansible is set up. So here we actually have our development server where you have your playbook, host files, and bar files all on that deployment server. Then it uses SSH to securely connect to your target server or wherever you're trying to send your information to. And so there's actually nothing you have to configure on that target server other than making sure your SSH connection is good to go. So this is just showing you the secure, simple setup for Ansible. So now let's go into the playbooks a little bit. So here's a large picture of the Ansible playbook, just showing you what it kind of looks like with all of its tasks, doing most of the process here that I could fit on the screen. Now we're going to break it down a little play by play. So here we have an input. So this is just showing an individual task. So it's showing that you have your name, which is actually naming your task, which we'll see where that comes in later. Here you have your yum, which is just showing a it's using the yum install, and then you go into the name, which is what you're actually deploying. So in this case, we're doing a yum install of development tools. So this last part here is actually the state present. So by setting it as the state present, it's actually looking through that server initially to see if it's already located. If it sees that that's there, it'll actually skip this process just to prevent any extra steps or processes. So for the output, to run your playbook, it's a simple command of ansible-playbook and then the location of where you have that playbook located. So then here it'll actually go through your play where it connects to their server, make sure all the data to connect to that server is good to go. And this is where that task comes into play, where you gave it that name, so you see which task it is. And the overall piece will show each individual task in that name. Then it'll go into the method here where it's saying this is okay, so I already had it loaded. The first time it'll say change, otherwise it'll actually say if something's broken or not. So from here, we're actually going to go into a live demonstration to show you what Docker is. So I'll hand it over to Brian to kind of explain a little bit more into detail.
All right. So the whole point of this demo is to show you how quick we can go from 0 to 100. We're going to take Wayne Enterprises custom application. We're going to containerize it. We're going to push it up to the cloud. We are going to pull it down into a remote environment, and then we're going to execute it and get it running just right here in class. So first we're going to show you, once we log into this remote environment, we're going to show you the end result and what we're working for. So this is Wayne Enterprises custom app. This is their polls. You can click on what's up, and then answer your poll, the sky, and there's it's working. Now, if we want to prove out Django, we can go the IP/admin. So how do we get to this end point? Well, let's go look at that custom app. So this is VS Code, a developer environment. What we're looking at here is, this is the custom application. These are the configuration files for it. And this is kind of a transparency layer showing your Docker containers. A lot of that's my work stuff, so you can ignore that. But this is what a Docker file looks like. We're grabbing Ubuntu. We're going through a few configuration steps with apt-get, grabbing our files, doing the pip install. The pip runs requirements.txt, which installs Django. And then finally, at the end, we grab that custom application right here, and we put it in the directory we want in Docker, and then fire off supervisor, which will manage everything. So now that we have this custom app built, or this custom app developed and ready to go, let's build it. So we're going to run a Docker build here. Docker /t. Period at the end of that. And it'll catch everyone. We need to establish the directory. So there, now we established the directory. There, it fires through the build. That's pretty quick. It's successfully built and tagged. And we're going to try to do this as quick as we can. So now it's built. Now we're going to want to push that to the cloud. Holly actually deducts this if this doesn't go really, really fast. So that's the whole point of this presentation. All right, so it's pushed. So now if we can show our repository in Chrome. And as you can see, this was bug one. I messed this one up. But Capstone test 2, it works. You can see 9 polls here. Now if you click on Capstone test 2, here's our custom deployment. And as you can see, Docker will tell you, hey, if you want this, all you do is got to do a Docker pull. So he's going to do that. We're going to go to the remote environment, do a Docker pull. Boom. And hit your browser. And then we'll just prove out that it's running. Just refreshing it. Or you can do the poll again. Yep, and there's what we were looking for. That's how quick. We went from 0 to 100 just like that. Now, oh yeah, Docker PS. If you want to prove out that Docker PS is a command showing all the current containers, and as you can see, it's running right there. we'll go back to our PowerPoint here. That was more of a tour de force demo. So, if we get to our slide.
It's always fun with all these technical issues.
I'm like hitting them wrong.
If everything went smoothly the first time, we'd be out of a job.
Exactly. There's always got to be something for us to fix.
Exactly.
Just in case you missed any other slides.
All right. So, next slide.
Okay.
So, what are, oh, wait, never mind. Right?
Yeah, we should show off Rancher
Yeah.
since we have it.
I got so obsessed with my Docker presentation that I forgot we were also showing Kubernetes.
I'm going to specifically show a nice management interface you can use with Docker called Rancher. Rancher is this nice web-based graphical user environment. You literally install it through Docker. It is its own Docker image. You can find a link to it off of Rancher's website. So we're going to give you a little bit of a tour of what this actually has. So we're in Google Chrome right now. You access this web page just by putting in the IP address of your device, followed by port 8080. That is the default port it installs to. You can change it during install if you want, but we're just using the default here. This is a really cool page we have here. This is what is called the host page. A host in Rancher is essentially just a machine that you have set up so that if you want to install containers, it'll get deployed right to that host. Now we have two of these running. We have a bit of information here that's pretty nice. We have IP addresses listed here, version of Docker, what version of CentOS is running, information about the CPU, RAM, and how much free storage is left. You also see a few containers here. You can see green circles around them. That means that they're running nice and good. And Caleb, if you would please click on one of the names here.
Yeah, absolutely.
Zoom out a few times. So this, what we're going to show you is a nice little graphic that this actually shows. It can show you in real time what your resource usage is on these separate machines. Here we are. It's a lot like you'd find, for instance, in a task manager. You can see what resources are being used. If you see spikes, for instance, you know that there's something wrong here. You might need to check on your server or something like that. But yeah, it's a nice little management interface that you can use with Docker, completely optional, but it just shows exactly how large Docker is and how flexible it is. So we're going to go back to the presentation here to wrap this up and tell you a bit more about our recommendations here.
So after seeing those demos, what are our recommendations? Well, our recommendation is a two-pronged or two-phased approach. Our first phase is using Docker. To manage this complexity, we're going to start with Docker, getting that custom app Dockerized, deployed. Once everything is managed and we start getting that container complexity, that's when we move to phase two and you implement Kubernetes. Kubernetes will manage that complexity really well. And so why do we choose these two tools? Well, they're both simple, they're both lightweight, they both have a really wide industry adoption rate, and they're both extremely flexible.
So over the course of the past few months, we all worked on our own DevOps solution. And so we've all developed a few opinions coming from people who have had no experience with any of this software before January. So we're going to go take a look at some of our grading, I suppose you would say, for some of our for various points on our different DevOps solutions. So the main points to take away is that Docker overall won out just for the reasons that we showed you. The main thing is that Kubernetes is in second place for what we call cost effectiveness. This is specifically for the statement of work, in which case we are only containerizing one app. And so in this case, Kubernetes would be overkill for that one container. As we said, as the network expands and they use more containers, that is a perfect time to implement Kubernetes.
So here you just see that we spent a total of 486 hours on this project. And just to show you a little bit of the learning curve, about 60% of this time was actually spent on research alone. And then the other 40% was a combination of the actual configuration and deployment of the website altogether.
And troubleshooting.
And troubleshooting.
So what lessons did we learn on this? Well, a technical lesson I learned is the inherent complexity involved in all this tooling. You take a custom app, you add in Docker and containers, and then now you add in Kubernetes. Things get wickedly complex extremely quickly. On a personal note, I'm a full-time developer, so I had to manage that, those hours and that time with this project. And you know, it can be a burden to try to find hours for each thing, but you know, that's the real lesson I took from it. Now, Austin, what did you learn?
I'd say my main takeaway was keeping an eye out for version requirements. Out of all the troubleshooting I did, this one was definitely one that held me up the most. I'd like to segue that into my personal lesson of being willing to ask questions and rely on your mentors and team members to try to help you through an issue. Especially Jordan Sussman, he helped me a lot here, as you can see from these Discord messages that we use to keep in touch. He helped me very much in figuring out these issues with the version numbers. Caleb, what would you say you've learned?
Well, Austin, I would say I learned, you know, when you get something completely new and you have no idea where to start, you're going to research and you're going to run into dead ends constantly through the process. Once you start grasping it, you know, you start having these dead ends and you start knowing where to look and where to go. And that kind of segues into my personal lessons. So I can see how all of how this project, how well it will benefit me in industry, and how exactly I can use this technology and this information and get into a place that I want to be and learn and grow. And that's my lesson. How about you, Austin? What about your lesson?
One of my biggest lessons that I learned real quick from the beginning of this project was making sure you constantly back up. For some reason, a couple of my setups, I went to go to test the deployment and it completely broke my server, so I started back from scratch. So making sure you have those backups is definitely a big importance to me. Some kind of lead into that big importance as well is the fact that I've never touched any of this equipment before. So not being afraid to jump into new equipment, learn these new processes. It can be very intimidating, but once you do it, actually, the more I learned about it, the more actually I was interested in it. It's able to learn more possibilities of what I could go from there.
So just want to extend a special thank you to Target Corporation. Thank you guys so much for sponsoring our project. Jordan, Jacob, you guys were awesome the entire time, very helpful. Couldn't ask for better sponsors. UW Stout, Holly, the advisement board for allowing us to present to you guys today. And everybody else that stuck around and watched. Thank you guys very much. Does anybody have any questions?
Yeah, so a quick one. So after going through all the tools, in your opinion, I guess I should say, which one was your favorite?
I would say my favorite, you know, I have a special place in my heart for Chef because I put so much time into like learning it. But I think I see like Docker is the fact like the containerizing and it's getting so widely adapted and it's so lightweight. Like I can see where, I mean, Docker you can basically use with Kubernetes, Chef, or Ansible. So I would say Docker. Docker is really like, it's a good starting point. It's a good starting point for like learning this technology and seeing like why containers are so important for this kind of technology and for this like quick deployment.
Kind of build off of that as well as with Docker, it has all those add-ons like Kubernetes and Rancher, like we kind of seen that when it comes to expansion on different things, especially when it comes to open source expansions, having that ability to add certain different GUIs to manage or just maintain it, anything you're looking at, I think that's kind of a big advantage to it as well.
Well, the fact it's all open source too. It's so cool that like you can just download this and play with it. You just learn about it.
It also has a cute logo. I love that whale.
So obviously you guys, as we saw, kind of information overload of all the things. How do you determine like who's going to do what, timing, and all that?
Yeah. We spent a lot of time trying to condense, trying to like just go through the main points and And since it's it's apples to oranges, like Ansible and Chef being like configuration management, Docker being a container, it can be utilized with all of them, and Kubernetes being like specifically for Docker. The main thing was for Chef and Ansible that because we chose Docker and Kubernetes as kind of our two-phased approach for Wayne Enterprises, with Chef and Ansible, we kind of wanted to put more of the information out there since we weren't doing like the live demonstration to just give everybody more of a general idea of how these actually work as well.
All fitting within our time frame.
Yes.
Yeah, each one of these tools could take, an hour presentation.
I think any one of those tools you could do a very in-depth analysis on. All of them have benefits.
Could we go back to your deployment test scoring slide?
Yes.
This is your personal
This is
research.
personal
Yes.
opinion.
Yeah.
That's why we got this.
We didn't want to make anyone mad with what we thought, and some people love their Ansible and Chef, and so.
With this, how we kind of chose with that options as well on what we picked for scores was just as a user level, not necessarily as a business level with these scores as well. So this is more user friendly from like a first time user or a professional user level, where all of a sudden that learning curve comes into play.
Kind of like when we started, how did we feel? And then at the end, when we were more comfortable, how would we compare it? So that's how we kind of got to these.
Oh, okay. So when you guys were researching scaling and you picked Docker to kind of win your presentation, what would you recommend for a much larger environment?
Utilizing the Docker containers, and then using like Kubernetes, Chef, Ansible, any of those would be a viable solution. It just depends on exactly what you're trying to do. They kind of have a learning curve to them. Chef's been around for quite a while. It can do tons of things. It can do so much stuff. But it might not be as intuitive to some people. But the main thing that I would say is if you were looking to do something like this for a large enterprise, containerizing for sure, but then going and actually seeing how your developers and anybody that's going to be a part of the project, how well they can grasp and learn these ideas. Ansible and Chef are really similar. It's just a lot of terminology differences and minus the underlying. Ansible is Python based and Chef is Ruby based, so there's some differences in that too. So that would be a major factor for sure.
I'd also say, depending on if you guys are using a cloud environment, like what cloud environment you're using could also play a major role in what one you decide to go with. I know Docker and Kubernetes can work with pretty much all of them from what I can tell. I want to work with that more, but definitely keep that in mind.
And with an operating system base as well, for example, Ansible is actually almost basically a Red Hat product. So it's Linux based only, as Docker can actually operate on, I believe, Linux and Windows together. So you can put that on anything. So it also kind of bases off of what you're using for software base as well when it comes to operating systems. So if you want to kind of bridge that port between each other, it'd be a good starting point with that as well.
So you kind of showed a DevOps slide. I guess the idea behind this is so that you can take it out of development and put it into production as fast as possible. Is that?
Yes.
So
yes.
How does that handle change control? Is there a way to maybe roll back if there's a problem? Do any of these tools offer that?
Yes.
Yeah, for example, I use Docker every single day at work, and so when I deploy a Docker container, you can tag. So you have your Docker container : latest, and that'll be a tag. Well, if you make a mistake and you want to redeploy your Docker container, you can do latest 1, and that's your kind of revision control. You still have latest, but you also have latest 1s. It can get a little complex. Most of my code controls honestly done in Git, and then once I know everything's solid, then I do the build and push. If there is something funky going on, then I can start doing the tags with Docker. Which is why I also took up Docker for this presentation. I already knew it, so
It's nice having an expert.
Another reason our hours were so much lower as well. Didn't take him as much time to get done.
Well, Brian did help me with Chef, and I do appreciate it. It's good having him. Anyone else? Any questions?
Who was the one that worked on Rancher?
I mean,
That used port 8080, right?
yes, by default, that's what it'll use to use its web interface, yes.
Is that Tomcat?
I'm not sure, I'm not familiar with
Okay.
it. Sorry.
Oh, that's all right.
Is that it? So then I guess we can move on to the next presentation.